Hello everyone, I am Hamed Ahmadinia, a senior researcher at University of Turku. Today I am going to present you some cases, retracted studies, which has been not only spreading misinformation through scientific world, but also harming the public. And also I'm going to show you some evidences that showing that even a retracted study after the withdrawing or correction is spreading misinformation through different platform and media ecosystem. Let's begin with one influential case. As you can see in this slide, there has been published this article in The Lancet in 1998 and claimed that MMR vaccine could cause developmental disorder in children. It quickly became one of the most discussed papers in medical research. This article was partially retracted in 2004 and fully retracted in 2010. Later investigation revealed major methodological problem, and a very small sample of 12 children discussed financial conflict of interest, including payments from illegal teams preparing a lawsuit, and eventually there was even evidence some of the data was manipulated or even fabricated. On this slide, you can see how widely the paper was cited and discussed both before and after retraction. And it is important to note that not all this attention was misinformation. Many articles and citations were actually criticizing or trying to correct the record. But because the study received so much attention, its original claim spread far outside the scientific community and reached the general public. Even with the clear evidence of misconduct, the study continued to shape public debate about the vaccine today. After the original study was published, many research teams carried out much larger and higher quality study to check its claim. On this slide, you can see examples from the major high-impact journals, including the New England Journal of Medicine. All of these studies find the same result. There is no link between MMR vaccine and autism. Some of them followed tens of thousands or even hundreds of thousands of children, giving very strong population-level evidence. So from the scientific side, the question was answered clearly, but as we will see, even when the science is clear, public opinion does not always change right away. What is interesting is that even after the retraction, the study continued to be cited very widely. On this slide, you can see citation data from Scopus showing that the paper appear in many journals articles, reviews, book chapters, editorials across different scientific fields. If we look at the site.ai classification on the right, we can see the most citations simply mention the paper. A small sample clearly criticize it, and a few still treat the original finding as if they were correct. This shows an important point. Retracting a study does not make it disappear. A retraction is a correction within scientific system, but it does not automatically stop incorrected claims from continuing to circulate, either in research or in the public. This article did not stay inside academic circle, it also reached a very large public audience. Altimetric score for this article is around 5,000, which is extremely high. It includes nearly over 2,600 social media posts and more than 900 mentions across news outlets, blogs, and podcasts. The sentiment analysis of X or former Twitter posts shows that most retractions are negative, meaning many people criticize the claim, but the level of visibility and attention remains very large. So even negative attention still increase the speed of the topic and keep it active in the public discussion. Here is a timeline showing altimetric mentions for the same retracted study from 2004 up to 2025. What stands out is that even the study was fully retracted in 2010, public attention peaks in 2017. And even in 2025, now, more than 15 years after the retraction, we still see regular activities, news mention, social media posts, blog discussion, and even podcast references. This shows that once misinformation enters the public space, it can keep circulating long after a correction is issued. A retraction does not automatically stop a story from spreading. Now let's have a look at broader societal impact of this case. We see lower vaccination rates, a higher risk of disease outbreak, a growing public mistrust in both vaccination and science in general. Unreliable scientific information, even when it's corrected quickly by the science community, can still have long-lasting negative effect on public health policy, individual behavior, and overall well-being of the society. For the second example, we look at the COVID-19 treatment, the study that spread as a preprint. It promoted a medicine as a possible treatment for COVID-19 and quickly gained a lot of attention. But later, researchers find major problem in the data, and the preprint was withdrawn. It was never published in a peer-reviewed journal. The lesson is similar to our first example. Even well-known preprint platform can unintentionally amplify early or unreliable finding. And once a story enters the media, the public space, withdrawing or correcting the study does not automatically undo its influence. Next, we look at how this case developed in the terms of media coverage, public attention, and its wider societal impact. So, this slide shows Google search interest over the time. For the second example, the graph reflects how often people searched for this treatment on Google. You can see that interest rises soon after the story begins to spread. There are several points where search actively increase again. Later, there is a much larger rise, followed by a slow decline. But importantly, the interest never dropped to zero. The long period of continued search shows the same pattern we saw in the first case. Once a story enters the media environment, it can stay active for a long time. Even when the science have moved or in the preprint has been withdrawn, people continue to look it up and talk about it. Here we have a news report from the BBC. It shows how media coverage can challenge unreliable scientific claims by pointing out problems in the studies behind them. In this case, BBC explained that many studies linked to a popular COVID-19 treatment had serious mistakes or possible sign of fraud, and the remaining studies did not provide strong evidence. This kind of reporting is important because it shapes how the public understands scientific corrections. But it also shows that once a claim spreads widely, even clear and well-written correction may not reach everyone who saw the original message. How media outlets present scientific updates plays a key role in whether the correction is noticed. The societal impact of the second case is significant. Promoting a COVID-19 treatment based on unreliable science mislead many people and may have caused real harm by encouraging treatment that did not work or by pulling attention away from the therapies that actually helps. This image shows how public health authorities try to respond to a confusion created by unreliable research. Here, the United States FDA uses a very direct message to warn people against using a drug meant for animals as a COVID treatment. It is a good example of how and when misinformation spreads widely. Official organization often needs to communicate in very simple and sometimes humorous way just to get people attention about it. This slide shows two ChatGPT replies that look completely different. When through the prompts, they are very similar. The first answer clearly says that the claim is not supported. But when the question is phrased in different way, the second answer sounds much more supportive, even though the topic is the same. This demonstrates an important point. People can influence AI results by simply changing how they ask the question from AI. A small difference in wording can lead to very different outputs, sometimes even the opposite. So the key message is that AI is not fully neutral. How we phrase a question affects the answer, and this can shape how scientific information is understood or misunderstood by the public. To conclude, I can say even we see that the science is doing the self-correction, but the question is remaining here. Is this correction is reaching to the public? In many cases, we see the retraction is happening and the science is correcting itself, but the misinformation is spreading very fast and louder among the different media platforms. And people, they rarely see the correction, they just see the misinformation. As a researcher or scientific institution and communities, this is our responsibility to make retraction visible to the public.